Welcome to 7th grade. Get ready for the lesson. Heights. The table shows Stephanie's height at ages 9 and 12. What was the change in Stephanie's height from 9 to 12? So at 9, she was 53 inches, and at 12, she was 59. So we'll subtract 53 from 59 to get 6 inches. Over what number of years did the change take place? So once again, we'll subtract 9 from 12. That's a change of 3 years. And write a rate that compares the change in Stephanie's height to the change in age. Express your answer in a multi-rate and explain the meaning. 6 inches in 3 years equals 2 inches in 1 year. And the reason why is we divide the numerator and denominator by 3 to get 1 in the denominator. And 2 inches per year. Stephanie's height increased by an average of 2 inches per year. Rate of change is a rate that describes how one quantity changes in relation to another. A rate of change is usually expressed as a unit rate. Stephanie's height changed in relation to her age. Find a rate of change from a table. Fundraising. The table shows the amount of money a booster club made washing cars for a fundraiser. Use the information to find the rate of change in dollars per car. And find the unit rate to determine the rate of change. So we have from 5 to 10 is plus 5. And from 40 to 80 is plus 40. Plus 5 cars, plus $40. Plus 5 cars, plus $40. Change in money over change in cars. So we have $40 for every 5 cars. The money earned increases by $40 for every 5 cars. We write it as a unit rate. We'll divide the numerator and denominator by 5. That will get the denominator to 1 for unit rate, and we'll get $8. So the number of dollars earned increases by $8 for every car washed. Check your progress. Planes. The table shows the number of miles a plane traveled while in flight. Use the information to find the approximate rate of change in miles per minute. So here's our table. We have time, 30 minutes, distance, 290 miles, 60 minutes, 580 miles, 90 minutes, 870 miles, 120 minutes, 1160 miles. So 30 minutes, 290 miles, 30 minutes, 290 miles, 30 minutes, 290 miles. Change in distance over change in time. So if we have 290 miles over 30 minutes, plane traveled 290 miles every 30 minutes. We can write it as a unit rate, dividing by 30, which is in the denominator. That gets our denominator to 1. If we divide 290 by 30 minutes, it's 9.67 miles. So the plane travels about 10 miles per minute. Mental math. We could have changed the numerator from 290 to 300 to easily calculate the problem mentally. Scaffolding questions. What is the rate of change of a plant that grows 5 inches per day? 0.5 inches per day. So we have 0.5 inches over 1 day. And what is the rate of change of a pool that is emptying 25 gallons per minute? 25 gallons over 1 minute, so 25 to 1. And what is 75 feet in 3 days in simplest form? So if we divide the numerator and denominator by 3 to get the denominator 1, we'll get 25 feet in a day. The rate of change describes how one quantity changes in relation to another. Find the rate of change from a graph. So the graph represents a distance traveled while driving on a highway. Use the graph to find the rate of change in miles per hour. To find the rate of change, pick any 2 points on the line, such as 160 or 120. And we'll put change in miles over change in hours. So 120 minus 60, which is the miles, over 2 minus 1, which is the hours. And we get 60 miles in an hour. Distance increases by 60 miles in 1 hour. So the rate of traveling on a highway is 60 miles per hour. Notice the rate of change is 60 miles per hour. Use the graph to find the rate of change in miles per hour while driving in the city. To find the rate of change, pick any 2 points on the line, such as 1 and 30 or 2 and 60. So we'll calculate change in miles over change in hours to get the change. So we have 60 minus 30 miles over 2 minus 1 hours, and that would be 30 miles in 1 hour. Distance increases by 30 miles in 1 hour, so the rate of traveling in the city is 30 miles per hour. Notice the graph is not as steep as example 2, and this rate of change is lower, 30 miles per hour, and the last one was 60 miles an hour, so it had a steeper climb. Notice the rate of change in this graph is 60 miles per hour, and notice this graph is not as steep, and its rate of change is only 30 miles per hour. The constant rate of change in y with respect to the constant change in x is also called the slope of a line. Slope is a number that tells how steep the line is. And the slope is the same for any 2 points on a straight line. Slope is the rate of change between any 2 points on a line. And slope equals change in y over change in x. Change in y is the vertical change. So on the graph to the left, the vertical change is 2, and the change in x is 1 on the graph to the right, or the horizontal change, which is the x. So we have 2 over 1 equals 2. Physical science, the table shows the relationship between the number of seconds y it takes to hear the thunder after a lightning strike and the distance x you are from the lightning. Graph the data, then find the slope of the line, explain what the slope represents. So there's the graph of the data. We have 0 and 0. Then we have 1 and 5. So you notice we go x, we go to the right 1, and then we go up to 5. Then we go to the right to 2 and up to 10, right to the 3 and up to 15, right to 4 up to 20, and right to 5 and up to 25. Slope is change in y over change in x. That's the definition of slope. So if we use 2, 10, and 5 and 25 as our 2 points, we'll put 25 minus 10 as a change in y over 5 minus 2 as a change in x, and we'll get 15 over 3. 15 seconds, 3 miles. Simplify. We'll divide out the numerator and denominator by 3 to get the denominator to 1. So for every 5 seconds between a lightning flash and the sound of the thunder, there's 1 mile between you and the lightning strike. Check your progress. Graph the data, then find the slope of the line. Explain what the slope represents. There is the slope. And we have change in y over change in x, which is the definition of slope. And if we have 4.46 and 0.23, we can do 6 minus 3, which is change in y. 4 minus 2 is a change in x. And we have 3 over 2. And the water level loss is 3 over 2. 3 centimeters per week. Every 2 weeks, the water level falls 3 centimeters. It's 3 over 2, not 3 over 1. Additional examples, the table shows the number of miles a car drove on a trip. Use the information to find the approximate rate of change. We have 1 hour, 65 miles, 2 hours, 130, 3 hours, 195, and 4 hours, 260. It's 65 miles per 1 hour, 65 miles per 1 hour, 65 miles for 1 hour. And if we take the change in distance over the change in time, 65 miles over 1 hour. So the car drove 65 miles per hour. And the graph represents the distance traveled flying in a plane. Use the graph to find the rate of change. So we have, we can pick any 2 points. So we'll pick 1 in 300 and 2 in 600. And change in miles over change in hours. So we'll have 600 minus 300 miles, and then 2 minus 1 hours. And that'll give us 300 miles over 1 hour. So the distance increases by 300 miles in 1 hour. So the rate of airplane travel is 300 miles per hour. Graph the data, find the slope of the line, explain what the slope represents. So if we have 3 hours is 45 minutes, or $45, 6 hours is $90, and 9 hours is 135. We made a graph. And then we'll have change in earnings over change in hours, and we can pick any 2 points. So we're going to take 6 and 90 and 3 and 45, and we'll subtract 45 from 90 and 3 from 6, and we'll get 45 for earnings over 3 hours. Now we need to divide by 3 because 3 is in the denominator, and we want that to be 1. So we have a unit rate of 15 over 1. Slope is $15 and represents the amount earned per hour. Here's your homework. So head to Google Classroom to fill it out, and I hope you have a great rest of your day. I will see you in class.